name is KHUZAINI AZLAN, matrix number A160277, will brief about the introduction of the shaft. The design shaft for this project is an induction motor shaft. The induction motor are widely used in industrial, commercial and residential device. The motor used for an electric fan is also induction motor. The induction motor shaft in this project is designed to apply on electric fan. Induction motor consists of stator, stationary part, and rotor, which is a rotational part. The shaft of an induction motor will be assembled with a squirrel cage rotor and the rotational part of the induction motor. The rotation of the rotor is due to the interaction between the winding and the magnetic field, which produce a torque around the rotor axis. Next, I will talk about the objective. Firstly, the objective is to design a shaft that is applicable for induction motor. Secondly, to conduct analysis on design shaft. And lastly, to design a shaft that is safe to be used.
Hi, I'm Shukri and I will explain briefly on methodology of this research. The research is analysis on shaft. There are many types of shaft in engineering world. We have decided to select shaft of an induction motor as our focus. Analysis were done to study the amount of stress or load held on the shaft. Then we designed the shaft using Autodesk Inventor 2018. We later select the appropriate material using CES EduPack 2016 and carefully analyze and mark all discontinuities or notches for further analysis, as this element is known as stress razor. All the calculations were used to determine the life expectancy of the design shaft. It also was used to determine its maximum load.
My name is Tan Jun Wei. I am going to present the analysis of the shaft. First of all, the reaction of the shaft are identified by applying the static load equation, which are summation of vertical force equal to 0 and summation of moment equal to 0. Before proceed to the static failure analysis, shear stress on different sections of the shaft are identified. Then, highest value of the shear stress will be used for the static failure analysis. Stress concentration on the notches are also identified. Static failure analysis is carried out on the shaft. Safety factor based on maximum shear stress theory and maximum distortion theory is calculated. Fatigue failure analysis is conducted on the design shaft. The material used for the shaft is steel. First and foremost, the fatigue strength of the steel and the angular limit need to be identified first to estimate the SN curves. Then, by using the SN curve, the fatigue strength of the steel at certain cycle life can be identified. Next, by plotting constant life fatigue diagram, we can identify the allowable shear stress for the steel. Then, the safety factor will be found by using the diagram. Final element analysis also done by using Autodesk Inventor 2018. By setting constraint on the keyway and apply torque on the shaft, we can run the simulation and get the result of the final element analysis. Now, I would like to present the discussion of this project. Fatigue failure analysis is a very important requirement of this design. One of the main ideas of this design was to design the shaft of an induction motor against fatigue failure. Fatigue cracks generally start at changes in section, notches, and keyway where the stresses is raised locally. Fatigue failure analysis need to be done on the stress razor. A notch shaft increases the fatigue life, and furthermore, it is important to mention that the notches should not be sharp. Notch area are the stress razor, and their presence reduce the resistance of a component to fatigue failure. In addition, the surface should be grinded, which is also a main part of the construction in the mechanical engineering. Calculation, we consider the safety factor for fatigue is relatively high. However, the keyway and the thread of the shaft is not taken into account when calculating the safety factor due to lack of research. The value of safety factor will be reduced if the keyways and the thread of hole are taken into account. Hence, the relatively high safety factor is acceptable.
For the conclusion, shaft is the main mechanical parts in machining. Transmitting power from the engine to the shaft must be safe and efficient. As a mechanical engineer, we must analyze the shaft component, depend on static failure, fatigue failure, and stress concentration factor, because we must achieve some value of safety factor due to the cost. In the conclusion, this project will really help for us to calculate based on actual application.